Alright, so this is where I left off with part 4. So, okay, so we're going to talk about the moon. Here's a very nice picture. This is a very famous crater on the moon that was caused by some impact. You can see it's very, very clear. Believe it or not, you can't see this crater with the unaided eye. You actually need just even a small pair of binoculars will do. Let me talk about two distinct features. The lighter areas on the surface of the moon are the highlands, and they are mountainous. The darker, smoother regions are called the maria, and the maria are that's just the Latin word for sea. Of course, it's not an ocean. It was certainly named long before we knew about the moon. That the moon is basically a dead world. It's a barren world, no atmosphere, no liquid water. When we sent the astronauts to the moon, they various groups of astronauts back, starting in the 60s and then into the early 70s, they actually made some great scientific progress on in our understanding of the moon and its origins. Its origin was always a mystery. Was it some trapped object that formed somewhere else in the solar system? Did it form with the Earth? These were all questions that we were asking, and no one knew for sure until, of course, the astronauts brought back some moon rocks, and we'll get into that in just a moment. The moon's surface, the astronauts found out, it has about 3 meters of really, really fine dust, and it's about 3 meters deep, and this is from the continuous pounding that the moon's surface gets from all the what we would call micrometeorites. So little tiny meteorites that when these things hit the Earth all the time as well. But the thing about the Earth, of course, is it has an atmosphere, and the tiny little micrometeorites simply burn up in the atmosphere. In fact, most of them they don't even leave enough light for the human eye to see. I mean, the larger ones, you can see a streak across the sky as what people still call, unfortunately, a shooting star, which has nothing to do with stars whatsoever. The rocks on the moon, of course, the astronauts took back. The ones from the highlands are older, okay, as it says here, about 4 billion years old, and then the darker ones, the ones that were found in the Maria regions of the moon, are anywhere from 3.1 to 3.8 billion years old, and there's a reason, of course, that the Maria ones are darker, and it has to do with lava solidifying. The internal structure of the moon, the astronauts actually brought up seismic detectors, and the moon does have just a tiny little bit of seismic activity, but almost, if you were standing on the moon and there was a moonquake, I guess you'd have to call it that instead of an earthquake, you would never even notice it. It's so slight that you'd never ever even feel anything. This is using some ideas that people had even before the astronauts went up, and putting the information that the astronauts collected from the moon all together. Let's go through the stages. So there was this object. We think it was probably an object that was about the size of Mars. In fact, the early solar system, as we'll get into later, had many, many more objects than the 8 planets that we currently have. We think that lots and lots of collisions took place, but one collision in particular, about 4 billion years ago, was a Mars-sized object that hit the early Earth, and basically just vaporized when it hit the Earth. Now, some of the material was kicked back out into space. Some of the material remained on Earth, and see that's through radioactive analysis. We can actually tell that the Earth and the Moon did come into contact long ago. Let's see. The reason that the Maria are different than the Highlands is because there was an intense period of bombardment. I mean, it's the moon's still being hit by things, but certainly not as frequently as in billions of years ago. But around 3.8, this should say billion. I don't know why it says million. 3.8 billion years ago, the moon, as I said, underwent a very intense bombardment, and at that particular time, there was still molten lava underneath the crust of the moon, the very early crust of the moon. And so when some of this material hit, this should say billion years, not million. During this period, from 3.8 to 3.1 billion years ago, those impacts some of them could break through the surface of the moon, and what that did is that caused lava to come and fill in where the impacts took place, and when the lava cools, it is noticeably darker, and we even see that on Earth, for example, when lava cools, it is definitely darker, and that is the explanation for why the Maria are darker and smoother looking than the Highlands. The moon and the Earth can actually be considered a system, a planet system itself. The thing about it, and this is actually, the moon Earth system is very unique in our solar system. The moon is about a fourth the size of the Earth. Now, it's not the largest moon in the solar system, but the ratio of the moon's size to the Earth's size is the largest in the solar system. Okay, so again, there's much, there's bigger moons out there in the solar system, in our solar system, of course, but the moon, the size of the moon compared to its host planet is the biggest, and that causes some interesting effects. So because the moon is so close and so big compared to the Earth, the moon actually tugs on the Earth. Of course, all objects in the universe tug on each other due to gravitation, but it's actually noticeable. And what that does, of course, is it affects us tidally. Okay, and we'll talk about the tides in just a moment. First, I want to go through the phases of the moon. The phase when the sun and the moon are in the same direction in the sky. Now here's a thing that you might notice right away. You might think, okay, well, when this happens, the way this is drawn right here, why isn't the moon's shadow hitting the Earth, for example? It looks like it lines up nicely, and the same thing happens, in this phase. Why isn't the moon in the Earth's shadow? And so the reason for that is the moon's orbit. When the moon goes around the Earth, it's actually tilted with respect to the axis of the Earth. It's tilted by about 5 degrees. So only when the moon crosses this thing called the ecliptic can there be an eclipse. And even when it does, sometimes the moon is too far, for example, and its shadow, the two parts of the shadow, the penumbra, the outer part of the shadow, might hit the Earth, but it'll only look as a partial eclipse, and it's only when the inner shadow, called the umbra, actually hits the Earth. All right, so let's get back to the phases of the moon. And the reason this is important, of course, is if the new moon occurred just as the moon crossed the ecliptic, then there's a chance for an eclipse. All right, so as I said, the moon is in the same direction in the sky as the sun, and that is called a new moon. In between the new moon and what's called the first quarter, when you look up in the sky and you see half the moon illuminated, there is what's called the crescent phase, and this part going from the new moon to the first quarter is called the waxing crescent. Waxing means increasing. And then after the first quarter, there is the waxing gibbous, and so that's between first quarter and full moon. And so full moon, of course, notice the angle. Let's go back to the angle between the moon, the earth, and the sun for first quarter. So notice you have a right angle, 90 degrees, right, for first quarter. And of course 90 degrees for what's called last quarter. Sometimes that's also called third quarter. So getting back to the full moon, notice the angle between the moon, the earth, and the sun. It's 180 degrees, right? The moon is on the opposite part of the sky as the sun. This would be like, for example, the sun sets at your location and then the moon rises. Okay, so they're 180 degrees apart. After the full moon, you're going to have the waning gibbous. Okay, so gibbous is when more than half the moon is illuminated, and then that goes to the last quarter, or as I said, sometimes called third quarter. And then after third quarter, this is the part when you see the moon, for example, in the morning, right? And this would be a waning crescent. So this is crescent. This would be a waning gibbous. This is, of course, over here is waxing crescent, and then waxing gibbous. All right. Let me also mention the fact that the moon, only one side of the moon faces the Earth. The moon does go, it does orbit. It does rotate about its axis, but it takes the same time it takes to go all the way around the Earth is the time it takes. Its axis to rotate, to rotate around its axis once. Let's see. Oh, so this is showing this thing about eclipses I had already mentioned. There is the path of the moon. Notice it's tilted with respect to the ecliptic, and of course, only when the Earth and the moon and the sun are in alignment, either 0 degrees or 180 degrees, can there be an eclipse. But of course the moon has to pass through the ecliptic, and usually the moon's shadow is always there, the Earth's shadow is always there, but usually the moon is above or below that shadow. So it's only when the umbra, when the umbra actually touches the Earth that happens. Oh, there's a nice picture of it. So here's the umbra is the inner shadow of the moon, and this is the outer shadow, the penumbra. The penumbra, that's, you can notice that it's not, I don't know, it's noticeable, but it's certainly not like being in the umbra, which is actually a pretty rare thing. All right, the tides, when the moon and the Earth are lined up, like during a new moon or a full moon, that is, they're. Oh, well, let me back up a little bit. Sorry. The tide's always there. The moon pulls harder on one side of the Earth than it does the other, and that's called differential gravitation. And so there's a bulge, a tidal bulge in the direction of the moon. I guess I'll have to finish this in another video.